syllabus of medicine. So please.
So this mid sem, which is on 12th of February in afternoon, and the timing will be same around 3 o'clock or so for maybe 1 hour and 15 minutes. Similar type of question will be there from the optics section, starting from uh, young double slit experiment, and then you have Michelson interferometer, then you have Wizzes, then you have thin, no, not thin film is not proper.
Sir, the coupled oscillation EM wave will not come in medicine, sir?
No, only optics section.
Okay, sir. Okay. From double
Only
slit,
optics
why
section.
did?
Yeah. Starting from, maybe we can include phase addition, okay, superposition of wave.
Sir, can you please give us a written mail about the topics which will come in the exam?
Okay.
Yes, sir. It will be so great for that.
Yes, written
Yes,
mode.
sir. Yes, sir. Yes,
Sure,
sir.
sure.
Please send us.
Yeah. So I'm just removing this one, and then I'm telling you the syllabus. So just I'm checking my content where we can put this.
Sir, what will be the total marks of the test?
20 marks.
20.
Sir,
20, yes.
is it subjective or objective, sir?
20 marks for 3 hours.
Not 3 hours. Who told you? Just
No,
one
it
and a
is 1
half,
hour and
maybe
15
1 hour
minutes.
15 minutes. Same
Oh,
pattern.
Then the same timing and all are present,
Yes,
just
yes,
the
yes.
slots are different.
Yeah. If we give for 2 hours, then we have to cover different section also.
so
So
do you have
because
to
there was
talk?
written some time from 14 to 17 like this, that is why we thought.
No. See, this is circular from the examination cell, but we are not conducting like that. Otherwise, what is the use of conducting the last two tests?
Yes,
If it
sir.
is just a mid sem,
Yes,
then we have to conduct for 30 marks or so, and then
yes,
for
sir.
end sem 50 marks. So in both exam, whole syllabus will be there. Okay, but that is not we are putting.
Yes, sir. Thank you.
Yeah, so for the syllabus for the class test 3, starting from phasor addition, so superposition of the wave, we have learned 3 different ways how you can add this. Algebraic sum, you have complex method, and then you have phasor addition. Then we have twin source interference. You have read about the young double slit experiment, biprism, double mirror, and so on. Then you had Michelson interferometer.
So
Yes,
can you tell the lecture number, sir?
pardon me.
So
Can you
lecture
repeat?
number. So
Lecture
lecture number
number.
L15. Like
Starting from the okay, lecture number. Okay, let me just check it. Yeah, so I think it is starting from, yeah, 14. 14, 15, 16, 17, 18. Yeah, so it has 3, 4, 5, 3, 4, 5, 6, 8. 8 to 9 hours. Did you get it?
so
Yes,
what did
sir.
you
Hello?
tell last line, sir?
Yeah, starting from lecture number 14. So you can just maybe note down, or maybe I can circulate to your email. Starting from phasor addition or superposition of wave, then you have twin source interference, just like you have read about the Young double slit experiment and biprism, double mirror, and so on. Then we had Michelson interferometer, then thin film interference, then we had wedge, Newton ring, Fraunhofer diffraction, grating, and polarization. So
the grating and
yeah,
all
Yes,
are
sir.
also on
It for lack of
12.
confusion.
yeah, very,
12
very simple question from the grating we can ask, because if you have very simple, suppose we gave n equal to some number 10 or 15, then what would be the intensity distribution and so on. So how it varies if you change the separation of the slit or width of the slit.
Sir, only the page number 68 to 77 are cut, and then after that again diffraction, grating, and polarization are coming.
Yes, yes. Okay, so if you just taking note of that, then you have whole diffraction is there, but okay, so let me just give you the page number detail. So starting from 78 up to uh, 85, 78 to 85 page number.
Yes, sir.
And we are not covering the resolving power of the instrument, so that is not in the syllabus. Then there is no double slit diffraction. Then we starting from 95 to 97.
Yes, sir.
Okay, so
The for this
78
diffraction slide, no.
Okay, sir.
78 to 85, and then 95 to 97. This is for the diffraction and diffraction grating. And for polarization, very simple, we have not covered many things, but starting from 122 page number to 'for ordinary and extraordinary days, in detail we have not discussed. So only up to 134. So 122 to 134 page number, and then a state of polarization we have discussed. So starting from 138 to 142. So just note it down for the diffraction, grating, and polarization. 78 to 85 page number, 95 to 97, then 122 to 134, 138 to 142.
Sir, which book are we talking about here?
Yeah, this is from the Saraswatan Sastri lecture notes.
Okay.
Sir, and there are certain differences in the interpretation of the experiments in the
Yeah.
book and the sir. So, which format means the question format is sometimes difficult. So, which format you follow in paper? Matlab, sometimes it is complete mathematical expressions in the paper, as in your slides,
Yeah.
and the book is slightly more theoretical with the text. Sir, so
Yeah.
which format you prefer in the exam?
Exam will be numerical based, so it doesn't matter if you are just reading this lecture notes or my slide, but as you know from text this class test 1 and 2, the question will be just numerical based. So you have to just uh, see how those formula were derived, and then yeah, that will work out. So basically all notes are open to you during the exam, so you can just follow. There will be no derivation. Did I answer your question?
Mm, yes, sir. Like, sir, I today could not find a diffraction integral in the book, sir. So I got
Yeah,
confused.
yeah. See, that's see, what I covered is for any unknown shape also you can do with that diffraction integral. Okay. You can so in the slide PPT we have put it a very common form to calculate the single slit diffraction pattern. Okay, but for any unknown shape, uh, if you just give a width of the slit, what we have considered the length of the slit. Okay, if you just allow z direction, so the slit was placed on the y direction, and if you allow some width in the z direction, then the integral will be a double integral. Okay, you got it?
Yes,
Suppose
sir.
you have a rectangular slit. Instead of just a simple slit, you have a rectangular slit. Then in that case, you have to have dz also. So you will be having a double integral. But in that case, this simple expression, what I showed you through the PPT, that is very tedious to calculate. But through the integral you can calculate, because you have to see the double integral and limit, from minus d by 2 to plus d by 2, and in the z direction maybe some limit is there. Okay.
Yes, sir.
Yeah. Yeah. So page number I just message you. Uh, this is from the lecture notes, so just follow this one.
Thank you, sir.
Yeah, so this will help you in the exam.
Excuse me, sir.
Yeah, tell me.
Sir, I had a doubt in the concordance and discordance part of the Michelson interferometer. Can I ask now?
Yeah, sure, yes. Yeah, so what was the problem?
So in one of the slides, slide 15, 59, I think there was a wavelength difference in the doublet. Yeah, that
Yes,
part.
yeah. Okay, let me
So
just
I, yes.
open that. Which lecture notes you are talking about?
Uh, the Michelson interferometer, I had got it from the Physics of Waves website. So
Okay. So did you check my PPT?
I couldn't find it actually, sir.
That is in the MS Team.
Oh, okay, sir. So actually, I couldn't understand. I mean, how the concordance discordance was going on.
Yeah. Okay, let me just show you that particular slide. Then it will be more clear. हेलो नहीं अभी चल रहा है Yeah, so can you just open, okay, just I'm saving this. Okay. So can you see this?
Yes, sir. Yes.
Yeah. So this is, you are talking about the measurement of wavelength separation of a doublet, very similar to what you are talking about the concordance or discordance.
Yes.
Okay. Yeah.
So I couldn't understand. I mean, we are using the same source of light. Then why is
Yeah.
the wavelength changing lambda 1 and lambda 2?
Okay. So see, you don't have a real monochromatic source, ideal monochromatic source.
Yeah.
Always you have some uh, spread in the lambda or spread in frequency. It is not like ideal monochromatic source, or you say ideal point source. There is no source like that. So always you have some spread in lambda. If you are just talking about any laser, that also has lambda, but that lambda will be very, very small.
Yes, sir.
Okay, just like if you consider just sodium light, that has two wavelengths, but if you are working with the sodium light, then you always work with the average of those two wavelengths.
Yeah.
Yeah. So that's why if you just see this expression, then you have this two expression for this maxima or minima. Okay, and then fringes will disappear if you have this difference is half or difference is 1, then it will reappear. And see, now you have to use this instead of lambda 2, you have to write lambda 1 plus delta lambda by 2. So we are just taking the mean of that spread. And if you use this one, the first order approximation, then delta lambda will be lambda square upon 2d. Okay, here we just, you can remove the index lambda here, 1 you can just remove, then delta lambda will be lambda square upon 2d.
Okay, sir. Okay, sir. Got it.
Okay.
Thank you.
Yeah. Okay. So basically, if you overlap these two images, then basically you can increase the sharpness of the image using multiple we have not gone through that multiple beam interference, but if you just go through Fabry-Perot interference, then you will see the rings were very sharp. So you can increase the sharpness of the ring by having multiple beam interference. So what
Yes.
so far we have talked about just the two beam interference.
Yes, sir. Got it.
So we have not gone through the multiple beams, so we will read about the finish and that the importance of the finish. That will be, means whenever some optical component is designed, just like interference filter, then finish will be the important parameter for any device.
Yes.
Yeah. Any other question? Done?
Yes, sir. Done. Thank you, sir.
Oh. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
तुम लोग कवर कर लोगे ना?